Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hi friends, welcome back to a new session. See, in the last session, we discussed about production of rotating magnetic field in three-phase induction motor and double field revolving theory we had taken. And if you want to change the direction of rotation of three-phase induction motor, we have to change the phase sequence, okay, without disturbing windings, physical displacement angle. This we had taken. In this session, we will take topic production of rotating magnetic field only. So generally, previously we had taken production of RMF in a three-phase induction motor. Now let me take production of rotating magnetic field RMF in a M-phase system. So see, let me see here. In M-phase system, saying how can you, if you want to produce a rotating magnetic field in M-phase system, what are the conditions? What are the conditions for production of rotating magnetic field? Just try to recollect from your previous session. There I told in three-phase induction motor, for production of RMF, three-phase current should be time displaced by 120 electrical, you told. Now I am saying in M-phase system, M-phase currents are time displaced by 360 degrees by M. And similarly, what about M-phase windings? M-phase windings are physically displaced by 360 degrees by M. Now, if you follow these two conditions, resultant MMF equals to M by 2. Previously, what you got? 3 by 2 FM. Now, I'll get M by 2 FM cos of theta minus omega t. You'll get. Please try to see from your previous session notes. There I told Fr equal to 3 by 2 FM cos of theta minus omega t we discussed. Now I'll get here M by 2 FM cos of theta minus omega t. I'll get here. These conditions for production of RMF in M-phase system, and this is the equation. You please try to remember M phase. I'm just saying M-phase system where M is greater than 2. That means these conditions and this equation is valid for only M greater than 2. Like example 3 phase, 4 phase, 5 phase, 6 phase, for any phases. Okay. Not for two phase and one phase. So the reason I tell you, so separate we'll discuss the two phase. Okay. So as of now, Fr equals to M by 2 Fm cos of theta minus omega t, where M is greater than 2. So please tell me observations from here, from this equation. What is the amplitude from this equation? Because I can write simply M by 2 Fm. And second observation. Fr is a function of what? Once again, theta comma omega t. That means what? It is varying with space and time. That means rotating magnetic field is produced in M-phase system also. And what is the speed of rotating magnetic field? I told you already. Speed of RMF is equals to ns. Don't confuse speed of RMF with the speed of motor. Speed of motor means n less than ns. I am saying is speed of RMF, which will be equals to ns. For three phase also, for in case of three phase induction motor, speed of RMF, yes, ns. For any phases, if you take a speed of rotating magnetic field equals to ns only. Okay. And here, yeah, you may get one doubt. So why? The conditions valid only for m greater than 2. Why it is not valid for m equal to 2? Means very simple. So I can write here for two-phase system. In two-phase system also, RM rotating magnetic field will be produced, but conditions are somewhat different. That's why I did not include this two phase in this M-phase system. What are the conditions? For production of RMF in a two-phase system? Means two-phase currents should be time displaced by 90 degrees electrical, and the two-phase windings, okay, should be physically or space displaced by, should be space displaced by 90 degrees electrical. So Fr is equals to, you'll get Fr equals to, okay, Fm cos of theta minus omega t, you'll get. Okay. So you may understand now why I did not include this two phase here. Suppose if we take these conditions from this equation, from this relation, 360 by 2 means 180 you'll get. This is not correct. For two phase system, for two phase induction motor, what are the conditions for producing RMF means two phase current should be time displaced by 90 electrical, two phase winding should be space displaced by 90 degrees electrical. That's why I just wrote this two phase separately. Okay. And what are the observations from that? Please tell me. What are the observations from this equation you are getting in two-phase system? Observations. Number one. What is the amplitude here? Amplitude I am asking. Fm. And here also as simply Fr is a function of theta omega t. Here also Fr is a function of theta gamma omega t. Fr is a function of theta gamma omega t. And third one, speed of what? RMF. Rotating magnetic field is how much? Here also speed of RMF is ns only. Okay. Right. Let me write some small note here, and you may get one doubt. So why did not include single phase? Here greater than 2 means 3 phase, 4 phase, 5 phase, for any phase. Okay. Yeah, I just told conditions for 2 phase also, but I'll not discuss now single phase, because single phase induction motor, there we don't have any resultant MMF. Resultant MMF will be equal to 0 in case of your single phase induction motor. That's why single phase induction motor is not a self-starting motor. We'll discuss single phase induction motor separately after completion of 3-phase induction motor. Okay. Now here let me give a small note here. See, if you take any phase except single phase, by default, please remember, if I say any phase, you just write in bracket, you just remember in bracket except single phase. In any phases, example 2 phase, you can take 3 phase, 4 phase, 5 phase, 6 phase. In any phases, rotating magnetic field is produced by default. See, Fr is produced and is varying with space, comma, time. And what is the only difference? So in any phases except for single phase, in any phases, rotating magnetic field is produced, but the only difference is amplitude. If you take a 3 phase, 3 by 2. If you take 4 phase, 4 by 2. If you take 5 phase, 5 by 2. If you take 2 phase, Fm. Okay. Only there is change in the amplitude. If you take any phases, speed of RMF means what? Ns. For 3 phase, 4 phase, 5 phase, 6 phase, any phase. If you take speed of RMF in 2 phase also, you are getting how much here? Ns only. The only difference is there is difference in amplitude of your resultant MMF. Okay. So let me write here. Rotating magnetic field is produced in any number of phases. In any number of rotating magnetic field is produced with any number of phases. You can write in bracket except single phase. Therefore, induction machine can also be called as polyphase induction machine. Polyphase induction machine. This is one note. And one more thing. So, though rotating, one more thing. I told you already, rotating magnet is produced with any number of phases. Okay. So that's why it is called. It is also called as polyphase induction machine. Then that means what? If I just discussed only 3-phase induction motor, we familiarly know that. Definitely RMF is possible with the 4-phase, 5-phase, 6-phase, any phases. But why 3-phase induction motor is only very famous? Very simple reason. Since 3-phase supply is readily available, We are designing 3-phase induction motor. That's the only reason. Suppose if you are generating 4-phase, you might have designed 4-phase induction motor also. So let me give that point also here. Among different phases, 3-phase induction motor is famous. Among different phases, 3-phase induction motor is famous. What is the reason? Since 3-phase supply is readily available. And one more note, as I already told you, so RMF is possible at any number of phases, and the speed of RMF for any number of phases is always ns. The only difference is change in amplitude. So let me give that point also. Speed of rotating magnetic field for any phases is ns. Speed of rotating magnetic field for any number of phases is ns. Okay. but there is change in the amplitude of resultant MMF wave. So resultant, if you take resultant MMF wave here, it's m by 2. If you take 3-phase, 3 by 2, 4-phase, 4 by 2, 5-phase, 5 by 2 FM, and for 2-phase it's a FM. So there is change in only amplitude, but if you take here speed of RMF, here ns, speed of RMF here also ns. Okay, so please note on this.